Hey everybody, glad you could join me for another clip on Internet Basics. In this video we're going to be going over subnetting. As always, you can access this material by following the link in the video description below. So subnetting can be a pretty difficult topic for some people, but it's very important in networking. It helps you figure out which IP addresses you can assign to your devices, and it helps you plan out your network in a more efficient manner. So subnetting, basically classical networks like we talked about before, we can break those down into smaller or sub networks. Some terms that you'll hear in subnetting, things like CIDR or slash notation. So basically that's just going to mean the number of ones that are in your subnet mask, and that represents the network portion. So like if our subnet mask was 255.255.255.0, that would be the same as slash 24, because there's 24 bits that have a value of 1 in that subnet mask. Another term you might hear is VLSM, or variable length subnet mask. Basically what that's saying is you could turn a single subnet into multiple subnets of different sizes, or that all of your subnets don't have to be the same size. You can allot one subnet for 100 users, and then the subnet directly following it could be allotted for 30 users, stuff like that. One thing to always remember is you cannot manipulate the network bits. Okay, the network bits come from knowing the class the IP address belongs to. Your defaults, if it's class A, it has a /8 or 8 network bits that are ones. Class B is a /16, and class C is a /24. So for an example, if we had a starting network of 192.168.0.0, that would be a class C. As we see this little list over here, 192 is in the class C range. So that default subnet mask is going to be a /24, which is a 255.255.255.0. So in that, we see all the ones that are turned on in the subnet mask. That represents our network portion. If we're going to subnet this, we cannot touch any of these bits. All we have to work with are the host bits that are remaining after the default subnet mask. Alright, so using subnetting, we're going to break down from the rest of that default network mask into smaller ones to allow a specific number of networks or to handle a specific number of hosts. Some equations that come in really handy when we're subnetting are your subnets are going to equal 2 to the n, where n is going to equal the borrowed bits from the host portion. And you're going to add ones from the left to the right. So if we had a /24 subnet mask, that would leave us with 8 host bits, because remember we have 32 total bits in our IP address. We minus that 24, we've got 8. You can see that represented right up here. We have these 24 subnet bits or network bits. It leaves us with 8 host bits. If we want to subdivide this into at least 5 subnets, we're going to need to borrow 3 bits. Because if we went 2 to the 2, and 2 was our borrowed bits, we would only be able to make 4 subnets. Whereas with 2 to the 3rd, we're able to make 8 subnets. So then after we've borrowed those bits, we're going to add those to the old subnet mask, which will get us a new subnet mask of /27. Yeah, and that'll be for each of the 8 subnets that we've been able to create. So essentially from left to right, we would add those 3 ones, and so now we would have 27 ones up here, leave us with these 5 host bits afterwards. Now another equation, it would be, if you want to get your hosts, you would use 2 to the h minus 2, where h is going to equal the number of host bits remaining. With this, you're going to assign zeros or reserve zeros from right to left. So if we want to create a subnet that can hold 100 users, we need to have at least 7 host bits. So like before, if we tried 2 to the 6th minus 2, it's only going to allow us for 62 hosts. But if we went 2 to the 7th minus 2, we can have up to 126 hosts, which is more than enough to hold 100. It's important that we allot for a higher number than we can have, unless we can allot for the exact amount. But if it's smaller, it's not going to work. So then after we've figured out that we need 7 bits, we're going to subtract those from the total bit count of 32, and we would know we have a subnet mask of /25. So if we came up here and we were to reserve 7 of these zeros, then there'd be 25 bits left. We'd turn this last one on because we're not reserving it, and that gives us our /25. The final thing that really comes in handy when you're subnetting is being able to determine your increment. Basically, your increment helps you figure out where the next network would start or where your network is supposed to start as well. Essentially, this is the bit value of the last one in your subnet mask, and by bit value I'm talking about the value of the bit in the group of 8 bits. So the first bit is 1, and then 2, and then 4, then 8, then 16, 32, 64, 128. So those values. Or if you don't want to mess with the binary, you can subtract the subnet mask from 256. Yeah. So example, if we had a network 1 of 192.168.0.64/26, that /26 is going to be the same as 255.255.255.192. So that subnet mask in bits is going to look like this. You'll have 26 bits, and then you'll have 6 host bits. So the last bit value right here, we went down, we'd have 1, this one's 2, then 4, then 8, then 16, then 32, then 64. Yeah? Or we could do 256 minus that subnet value of 192 that's in the last position, and that would also give us our 64. So what that tells us is that the next network would start at 192.168.0.128, because that's 64 on top of where our first network started. The last thing to remember with subnetting when you're doing variable length subnet masks is you need to assign the largest subnets first and then work your way to the smaller ones. So that's all for this subnetting video. I'm going to try and get some more resources for you guys to practice this. I hope that I can. If it's in the link in the description below, then go for it. Definitely practice this as much as you can because it is very important. Otherwise, I hope you enjoyed this video and I hope you stick around for the next one. We'll hop into some binary examples.